Okay guys, I'm going to go over problem number 3, and associated with problem number 3 is 6. So problem number 3 asks us to graph the feasible region. We'll start with x is greater than or equal to 0. I have already taken the liberty of doing that, so here's my graph. This is the line x is greater than or equal to 0, so I'll just write that there, x is greater than or equal to 0. And then the next equation is y is greater than or equal to -1, so that's down here. So this is the equation y is greater than or equal to -1. The next equation is y is less than or equal to x plus 1. My y-intercept is 1 here, and I go up 1 and over 1 and up 1 and over 1. And so this is the equation y is less than or equal to x plus 1. And I have to be below that line there. And then finally I have y is less than or equal to -1/4 x plus 6. Y-intercept is -6 I'm sorry. I go down 1 and over 4. And so here is the line y is less than or equal to -1/4 x plus 6. And there again I have to be below that line. Okay, so you can kind of see my feasible region. It starts here, goes there, there, and over here. Okay, so that's my feasible region. Let me kind of clear some things off here. Get rid of some of these points so you can see the feasible region a little better. So it's kind of like the navy blue here. That's the feasible region. Okay, so we did number 3. Number 6 asks us to minimize for the objective function 3x plus 5y for the constraints from exercise 3. So in order to do that, okay, after we've done or figured out the feasible region, we have to find all the corner points for that feasible region. Some are easy to find, some you have to do a little more work. The corner point here, I guess, is kind of easy to see. Okay, notice here that this is x is 0 and y is -1, so that's easy enough. Here, this corner point, again, I guess is kind of easy to see. So again, we have the line x is 0, and then we have the equation y is equal to x plus 1. So the y-intercept is 1. So the corner point of vertex is x is 0, and then y is 1. So that's kind of easy to see. This one here, even though we can see from the graph that the intersection is 4, 5, we're not always so lucky. So maybe we'll have fractions or decimals that we have to worry about, but we still need to verify this. Okay, so how do we go about finding the intersection? Well, we have two equations. We have y is less than or equal to x plus 1, and then we have y is equal to less than or equal to -1/4 x plus 6. So when we find the intersection, we don't care about the inequalities, we just want to find where they're equal. So we'll just go y equals x plus 1, right? And then the next one, y equals -1/4 x plus 6. So the most important equation or substitution problem we'll ever have in chapter 3 is we have y is equal to one thing, y is equal to the other thing, set that one thing equal to the other thing, and solve. So important in this chapter here. So let's do that. So we have x plus 1 equals -1/4 x plus 6. So we solve for x. Alright, I'll add 1/4 x to both sides. I'll get 5/4 x over here on the left. 1 and 1/4 is 5/4. And then I'll subtract 1 from both sides, so 6 minus 1 is 5. So I need to solve for x, so I'm going to multiply by the reciprocal 4/5. And so this will give me then x is equal to 4. And take x and substitute it into the equation up there, and we get y is equal to 4 plus 1, or 5. So I've verified my vertex right there, 4, 5. Okay. The next one we have to find the vertex for is that there. So again, notice we have two equations here. We're solving a system of equations. That's what chapter 3 is all about, solving a system of equations. The first equation is y is equal to negative 1/4 x plus 6. And the next equation, okay, well that's the line y is equal to negative 1. Again, we don't care about the inequalities. We're finding the intersection, so. Alright, and then, so again, we said y is equal to y. Negative 1 equals negative 1/4 x plus 6. Okay, so I'll subtract 6 from both sides. I'll get negative 7 equals negative 1/4 x. Multiply both sides by negative 4, and I get 28 is equal to x. Okay, so I found x. I had y, and so my vertex is 28, negative 1. Okay, so we found all the corner points, all the vertices. Now, after we've done that, then we can go ahead and minimize the function. So let me kind of clear off the board here, so because we don't need this. So let me kind of clear some things up here. All right. And I guess I can get rid of the functions as well, because we've found all the vertices. Alright, so, and then make this a little easier. Delete that. Delete that. And we'll do delete that. Okay, so now we can go ahead and minimize the function. So here we have the vertices, so let's make our xy table here. So here I'll have my xy table. I'll list my vertices and the objective function. So we have p equals 3x plus 5y. Alright, so my vertices are 0, negative 1, 0, 1, 4, 5, and then 28 minus 1. Okay, and then we'll just substitute an x and y into our objective function. Well, 5 times 0 is 0, or 3 times 0 is 0, and 5 times negative 1 is negative 5. 3 times 0 is 0, and 5 times 1 is 5. 4 times 3 is 12, and 5 times 5 is 25, so this is going to give us a total of 37. And then 3 times 28 is 84, and then negative 1 times 5 is negative 5, and 84 minus 5 is 79. So the minimum occurs right here. Okay, so our minimum value for is negative 5, and that occurs at 0, negative 1. Okay, so there. So we completed problem number 3, and we minimized it according to the objective function 3x plus 5y. So what did we have to do? We had to graph these equations. We had to graph the equations. Find a feasible region, which is what we did here. Okay, find the vertices. Find all the vertices. Plug those vertices into our xy table and evaluate our objective function. So, a lot to do, but that's chapter 3. So we'll go on and we'll do problem number 4 and 7.